Welcome to Ziba Academy. In this tutorial, we'll create Pong game using Rust programming. Extern crate was used to explicitly include external libraries, crates, into your project. The extern crates involved 1. Gluten_window, it creates a window with OpenGL context, enabling rendering graphics inside a window. Useful for creating the rendering surface where OpenGL drawing occurs. 2. Graphics, the core 2D graphics library for rendering shapes, images, and text. 3. OpenGL_graphics, acts as a bridge between the graphics library and OpenGL. 4. Piston, it is game engine in Rust that ties together windowing, input, graphics, and other game-related features and provides a framework to manage game loops, event handling, etc. Next, 1. Use std process, it imports the process module from Rust standard library. 2. Window settings, it imports the window settings struct from the piston crate. It used to configure and create application windows, such as setting size, title, whether the window is resizable, etc. 3. Event_loop::event settings, events, used to imports event settings and events from piston. Events like manages the event loop, allowing the program to listen for and respond to events like input, window resize, etc. 4. Input::button, key, press event, release event, render args, render event, update args, update event, used imports various types related to input handling and the game loop. 5. Gluten_window imports the gluten_window struct from the gluten_window crate. This is the OpenGL renderer from the OpenGL_graphics crate. It used to actually draw shapes, text, and the ball/paddles on the screen. Left player state with some attributes. 1. Left_score, by 32 right arrow the score for the left player, probably increments when the ball goes out on the right side. 2. Left_POS, by 32 right arrow the vertical position of the left paddle on the screen. 3. Left_bell, by 32 right arrow the velocity of the left paddle, how fast it moves up/down. Right player state with some attributes. 1. Right_score, by 32 right arrow the score for the right player. 2. Right_POS, by 32 right arrow the vertical position of the right paddle. 3. Right_bell, by 32 right arrow the velocity of the right paddle. So together, these define both players' paddles and scores. Ball state with some attributes. 1. Ball_x, by 32 right arrow current x position of the ball. 2. Ball_y, by 32 right arrow current y position of the ball. 3. Bell_x, by 32 right arrow velocity of the ball along the x-axis, positive right arrow moving right, negative right arrow moving left.
This function handles rendering, drawing, the game scene each frame. Use graphics * import functions like clear, rectangle, and helpers like rectangle square from the graphics crate. Colors in piston are R, G, B, A, values between 0.0 and 1.0. Where background is teal, 0.0 red, 0.5 green, 0.5 blue, 1.0 opacity, and foreground is blue, 0.0 red, 0.0 green, 1.0 blue, 1.0 opacity. It draws two paddles and shapes, left and right, at fixed X positions, with Y positions based on the game state, self.left_POS, self.right_POS. It draws the ball at its current, X, Y, position, self.ball_X, self.ball_Y. The update function handles all the game logic for each frame. It moves both paddles up or down based on their velocities while keeping them within the top and bottom screen limits, then advances the ball's position along the X and Y axis. If the ball goes past the right edge, it reverses direction and checks if it overlaps with the right paddle. If not, the left player scores, and the ball resets to the center. The same happens on the left edge, giving the right player a point if the left paddle misses. If either player reaches 5 points, the game prints a win message and exits. Finally, the ball is made to bounce off the top and bottom edges of the screen by inverting its vertical velocity when it collides with them. Press function. The function is called whenever a key is pressed. Args tells us which button was pressed. The if let end button keyboard key equals args checks if the event came from a keyboard key, ignores mouse buttons, gamepad buttons, etc. Where match key matches which key was pressed. One right player uses the arrow keys, up and down, to move their paddle vertically. Two left player uses W, up, and S, down. Instead of directly changing paddle positions, it sets their velocities, -1 for up, 1 for down. On each update, these velocities move the paddle smoothly until the key is released, handled in a separate release function. Release function. This function is triggered when a key is released. Just like in press, it first checks that the event came from a keyboard key. If the released key is one of the paddle control keys. One up or down rightward arrow stop the right paddle by setting right_vel equals 0. Where W or S rightward arrow stop the left paddle by setting left_vel equals 0. Set the velocity to 0 means the paddle won't move anymore, until another key press sets it again. This main function is the entry point of your Pong game. Let's explain it step by step. We choose OpenGL version 3.2 for rendering graphics. Window settings creates a window titled Pong with size 512x342. Exit on ESC game exits when escape is pressed. Build, unwrap, it builds the window or crashes if it fails. Where our app holds everything, scores, paddles, ball, and the graphics engine. At the start, paddles are at the top, POS equals 1, ball starts at 0,0, moving diagonally down right, vel_x equals 1, vel_y equals 1. Let mud events equals events new, event settings new. It creates the game loop, which continuously provides events, render, update, input, for the game. Also we have main game loop for render, update, press, release where. Render draws everything. Update moves paddles, ball, and check scores. Press starts paddle movement. Release stops paddle movement.